Hello, my name is Leimin. Today I will present our study on redesigning human-robot interaction in response to robot failures. Robots are increasingly used in today's public spaces, such as in the airports or on the streets. In this work, we adopted the participatory design methodology to understand what are people's expectations and perceptions of robots in public spaces. PD methodology has been used in HR research to incorporate users' feedback. However, participants in existing studies are rarely shown a tangible realization of their design. Therefore, we propose a novel PD methodology consists of active prototyping of robot behaviors in a simulator and on a physical robot, which facilitates iterative design and evaluation. In our PD workshops, the participants are introduced to the programming tools and workshop goals first. They then engage in a small group behavior prototyping session. Finally, they demonstrate the designed robot behaviors and discuss their experiences. We conducted the PD workshops remotely with the same participants attending both a simulator-based and a robot-based workshop. We used the Pepper humanoid robot and its accompanying simulator. To facilitate participatory prototyping, participants are also provided with the RISE and user programming interface, a cheat sheet listing all available robot functions, and a translator who is a technical expert that can answer their questions. The 12 participants were divided into 2 groups randomly before the programming session, each with their own robot and translator. Here we demonstrate the setup for the simulator PD workshop. On the left is the Pepper robot simulator. On the right is the RISE interface, in which basic robot functions can be customized and combined to form a more complex robot behavior. After the simulator PD workshop, we selected a robot behavior shared across participant groups, in which the robot attends to a lost child by engaging the child to wait with it while signaling a human staff to help. The participants redesigned this lost child robot behavior in the robot-based PD workshop. As shown here, participants attended the robot-based PD workshop remotely. In addition to the RISE interface and the translator, participants saw a live stream of the physical robot, as well as its status, such as the view from its onboard camera. Here is an example of a robot behavior implemented in RISE that is executed on the physical robot. Our exploratory study yields 3 major findings. Firstly, people's perception of whether a robot exhibits a failure or not depends on the context and their expectations. For example, participants discussed how a sentence the robot said was perceived as creepy once they saw the execution, and their concern of the robot's inability to interact with a child with autism. Secondly, we found that people's expectations are fluid and shifts rapidly with their observations. In particular, participants simplified their design of robot behaviors and grounded their expectations of the robot towards its actual capabilities throughout the workshops. Thirdly, we found that the use of robot simulator allows for agile iterations and for envisioning new designs, while having a physical realization on a robot provides rich context for evaluating and adjusting the design in SIGCHI. I would like to thank my collaborators from Monash University and from Tokyo University of Agriculture and Technology. If you would like to know more about the Robots in Public Spaces research project, please read our paper or scan this QR code for our webpage. Thank you.